Okay, we're going to go over section 6.3, logarithmic functions. So logs are the inverses of exponents. So like adding undoes subtraction, logs undo exponents. You can go back and forth between these. So A is the answer in an exponential equation, and we call it the argument in the log function. B is going to be the base. So it's the base of the exponent or the base of the log. And then X is your exponent, which is also like the result over with your log. So by rearranging those, you can go back and forth to each one. So for example, our base of this one is 6. So we would write it as a 6. The argument of the log becomes the answer in the exponent, and then the other number becomes your exponent. So then these few are going to seem silly going back and forth, but knowing how to do this is going to help you in future sections. So if we do the same thing on all of these, the base is 3, the base is 10, the base is 5. So we're going to write those as our base, 3, 10, 5. Then the argument becomes the answer. So we're going to say equals 1,000,000, equals 9, equals 25. And then the other number becomes the exponent. So 10 to the 6, 3 squared, 5 squared. So let's do some with x's, not that it's any different. Base is 8. The argument becomes the answer. And then the x is the exponent. All right, let's do the same thing. Base. So it's x on this one, 4 on this one. The argument becomes the answer. And then what's left becomes the exponent. So that's how you go from log form, that's with the log, to exponential form with the exponents. So some quick facts about logs. Can you take the log of a negative number? No. So the argument always has to be positive. It's never 0. Your base is also positive. The other things will give you imaginary numbers, but we're only dealing with real numbers with logs. So your base has to be positive. Your argument has to be greater than 0. So let's convert some more. These times we're going to go from exponential to log. So we take that base and we make it the base of the log. We take the answer and we make it the argument of the log. And then we take the exponent and put it as our solution. So same thing, the base becomes the base of the log. The answer becomes the argument of the log. And the exponent becomes what you're trying to get. So if we do the same thing for the last two, the base of 1 is 3. So log base 3, log base 5. Then we take our arguments, or answers, and make them the arguments. And that's going to equal our exponent. So that's just how you go back and forth between the two forms. Now let's look at some examples where you're actually going to be solving the equations. Oh, I lied. There's 2 more. Let's do 2 more. Base is 10. Base is 2. So log base 10. Log base 2. Then we take our argument, our answers, and make them the arguments. So 1 over 10,000, 1/2. And then it's going to equal the exponent. So equals -4 equals -1. Now notice the answer, the exponent, can be negative. It's just the base and the argument that can't. Just keep that in mind. All right, now let's look at solving some. So right now, all you know is that a log is a thing. You don't know what to do with it. So let's rewrite this one. 4 to the y equals 64. So this is our logarithmic form. This is our exponential form. And now we're going to try to figure out, well, 4 to what power is 64? Well, 4 to the first is 4. 4 times 4 is 16. 4 cubed is 64. So to make this true, y equals 3. So let's do the same thing over here. We have 11 to the y equals 121. I did that backwards. Sorry. The base is 121. 121 to the y equals 11. So now 11 squared is 121. The square root of 121 is 11. And as an exponent, square root is a half. So this is like saying 121 to the 1/2 equals 11. So y would equal 1/2. All right, let's look at this one. Base of 3, exponent of y, answer of 1/27. We're looking for 3. So 3 to the first is 3. 3 squared is 9. 3 cubed is 27. So I can rewrite this as 1/3 cubed. Because we're on the bottom of the exponent, it's like saying 3 to the -3. That's what puts it on the bottom of the fraction. And now we know y equals -3. So we've got one more here. 2 to the y equals 1/32. 2 to the first is 2. 2 squared is 4. 2 cubed is 8. 2 to the fourth equals 16. 2 to the fifth equals 32. So this is the same as saying 2 to the y equals 1/2 to the fifth. That fraction makes it 2 to the -5th. So y equals -5. So when they're the same power, like this base is the same for all of them, you can do it this way. That's not always going to be the case. So let's keep going. Base 10 is how we write our numbers. In our life, each place, like for place value, is 10 times the place before it. So we go from ones to tens, tens to hundreds, and so on and so forth. So we work in base 10. That means we're not going to write base 10 on the log. So if you just see something like this that says log, that means base 10. So the hidden number there is 10 because that's what we write in. You can type the log in the calculator. So you have your calculator here. Log is this button right here. It literally says log. That log is always base 10. So if you type log 1000 in the calculator, you get 3. If you type log 321 in the calculator, you get 2.507. If you type log 234 in the calculator, you get 2.369. Most of the time, the logs are going to be yucky numbers like that. They're only going to be a whole number if it's a power of, like we did here, like has the same base. Another base is E. We talked about E in section 6.1. E is that, it's the whatever, I don't even remember what it is anymore, but it's a number like pi. That base if you have log base e, we call it the natural logarithm. The reason we do that is because it's used in a lot of real life things. If we're talking about half-lives and continuous interest, like things that are real, a lot of the times it's e. So you're going to use the ln button instead. That's how you say log base e. So the ln button is right below the log button. Oh, why is it doing that? Okay, let's try this again. The ln button is right below the log button. So it's right here. It says ln. So that's log base e. So if you type ln 500, you get 6.215. If you type ln negative 500, so you're either going to get an error or you're going to get an I because it's not real. Remember, you can't have a negative argument. So for the purposes of what we're going to do, there's no solution. There's no real solution. On your calculator, it'll look weird like this with a plus and an I. So that's what that negative is going to do. Then we can also do ln 4/5. So ln and then 4 divided by 5, and we get negative 0.223. Again, the answer can be negative. The negative answer is okay. You just can't have a negative argument. Negative answer, okay. All right. So now I'm going to show you how going back and forth between the two forms is helpful. Like 10, I can't do 10 times 10 or 10 times 10 times 10 to get 500. It's not possible. So instead, we're going to rewrite it. We're going to say log base 10 of 500 equals x. Log base 10 is how we write our numbers, so I can just type that right in the calculator. Log 500, and I get 2.699. So if I do this one, log base 10 of 8,500 equals x. Log base 10 tells us the calculator, so we don't have to write the 10. I can just type that right in my calculator, and I get 3.929. All right, so when x is the exponent, you're just going to be able to type stuff in your calculator. Now let's look at the next one. If I rewrite this, the base is 3. It's going to be squared, and that equals x. Well, now I just have to do 3 squared. So 3 squared is 9. All right, so this one, our base is 18. That is squared, and it's going to equal x. So I just do 18 squared, and I get 324 equals x. So if the arguments you're looking for, it's pretty straightforward. All right, let's look at another one. This one, our base is x. Our exponent is 3, and it's going to equal 64. So you may look at that, and you may know 4 to the third is 64, so x is 4. You might be able to just do that. But if you don't know that, you can take to the cubed root of each side, which, as a refresher, the math button, that's this one, the one right below the green. And then number 5 will give you the way to type that in. So you would type 3 as your index and then 64, and it'll give you 4 that way. So you can do that either way. You may know it, you may not. You don't really have to. So let's look at this one. I didn't mean to get rid of that. So this would be x to the 4th equals 16. So if I take the 4th root of both sides, math 5, 4, 16, I get 2. All right, we're going to do a couple more. So we don't know what this equals, so I'm going to stick an x there so that I can rewrite it, because you don't know how to type that in the calculator. It's a process. So instead, I'm going to make it equal x, and I'm going to say 3 to the x, so that's this 3 to the x, equals 3 to the 5th. If the bases are the same, the exponents have to be the same, so x equals 5. All right. This one, we're going to stick an x over here. Now, before we do anything, we need to get the log alone. So I'm going to divide both sides by 6 to get the log alone. X over 6. So now I'm going to say 5 to the x over 6 equals 5 to the 12th. Since the bases are the same, I can say x over 6 equals 12. And then I multiply both sides by 6, and I get x equals 72. So that's just how you can go back and forth between exponential form and logs, or between logs and exponential form, to solve for x in a few different ways. That is section 6.3. Let me know if you have any questions.